Hello, I'm Nancy Strickland from IT Mentors, and this is one of a series of videos on Visual Studio 2010, the Beta 2 release. This video covers enhancements to ADO.NET. I'm going to talk about what's new in ADO.NET for Visual Studio 2010. Now, Visual Studio 2010 is only in beta release, Beta 2 at this point, and ADO.NET is in CTP, the Community Technology Preview. So what I'm going to show you is what you can do with ADO.NET in those versions. I'll start with some background by explaining in general what the entity framework is and how to use it, and I'll show you how you can use both link to entity and query method expressions with the EF, the entity framework. And then I'll show you 3 new features of the entity framework: model first development, and then plain old CLR objects, those are called POCO, P-O-C-O, and code generation, and then lazy loading. And then I'll also tell you a little about some of the new ADO.NET features that are going to be added in later versions of Visual Studio 2010. But of course I won't be able to demonstrate those. The entity framework for ADO has been around for some time, and Visual Studio 2008 with the .NET Framework 3.5 in Service Pack 1 supports it. But if you haven't worked with the entity framework before, let me start by explaining what it is. The purpose of the entity framework, it's often abbreviated EF, is to let an application work with a logical schema, a conceptual model of entities and their relationships, without having to specify exactly how to store that data or how to retrieve it. The data could be stored and retrieved from different sources, not just a relational database, but of course that's a very common data source. If your app is going to work with data from a database, then using the entity framework, that'll free the application code from having to know about how that particular relational database was designed. And that not only makes the code shorter and easier to write, but it can also protect the code from changes in the way that the database is organized. The framework, the entity framework, handles the task of converting data in objects to and from the data in relational databases for you. Now, a general term for this technique, this feature, is Object Relational Mapping, ORM, and the ADO.NET Entity Framework is Microsoft's implementation of that concept. The entities in a conceptual model don't map directly to tables. It's not a one entity equals one table equivalence. If they did, there wouldn't be much work for an entity framework to do. But the information about one entity might be kept in more than one table. For example, a customer's phone number might be kept in a table of phone numbers that was separate from the general customer table and then use a key to link them together. Or if a database had a many-to-many mapping, there might be a table that was used to create the links between those tables, and that table, the linking table, it isn't a conceptual entity at all. And then in some cases, a table might be partitioned, so some of its columns might be in a separate table, and the conceptual model would show all the properties in the same entity conceptually, so the two tables together would be mapped to a single conceptual entity. The job of the EF, the entity framework, is to handle all this for you and create for you a logical view of an entity, no matter how the properties of that entity are spread among tables. So when you use the EF, you can then just refer to the phone number property of a customer entity, like this last line here, customer1.phone.area code, without having to know or having to care if the area code actually comes from some other table. So that lets you program in a very natural and intuitive way and kind of shields you from the physical peculiarities of the database itself. The entity framework can create entity types. The entity types are logical types, conceptual types that are based on the data in the database, and then the application can create instances of those types. The entity type is a class, and it has properties for data and for the relationships with other entities. And the application can create instances of the class for specific entities. Now, the entity types and the objects are an obvious way to represent a logical object in object-oriented code. But you could also use other ways. For example, you'd use an XML representation of a logical object if you needed a serialized stream of data. The entity framework itself just gives you a logical view of the data, which can then be represented in code in whatever way is logical, various ways depending on what you're doing. So the entity framework creates a logical schema, maps it to the physical schema, and that mapping is the entity data model, the EDM, and it's saved in an XML file with the extension EDMX. And then the ADO.NET Entity Framework uses that EDM, that data model, to actually perform the mapping. So then the application can work with the entity instances. It's the entity framework that handles things like joins or traversing a relationship, whatever you need to do to actually get the data. If the application makes a change to an entity and then chooses to update that entity, to persist it, then the framework knows which table the information came from, and it handles the SQL update command. Actually, it uses a specialized version of SQL that's called eSQL, which stands for Entity SQL. It can convert that into whatever version of SQL the underlying database uses to do queries if it needs to. Let me quickly show you how that works. If you're already familiar with this, you can just skip ahead past this demo and the next, which are kind of an intro to the entity framework. Now, I already have Visual Studio 2010, the Beta 2 version, open here, and now I'm going to start a new project. And this will be a Windows Form application, and I'm just going to leave it right here on the desktop. And it's going to use the entity framework to create a logical entity model from an existing database. So I'll start by right-clicking my project and saying Add New Item. And the type of item I'll add is an ADO.NET entity model. So here it is. I'm going to leave it called Model 1 EDMX. That's the extension. I'm going to generate it from an existing database. And in this case, I'm using Northwind. I already have the connection ready, or I could create a new connection in the standard way that you create new connections in any Microsoft product. And then I'm going to go ahead and put the data in the current project. You certainly don't have to do that, but this make it run just a little bit faster here. And now it's checking the database. I'm going to include all the tables, so I'll check here to get them all. And here is my entity model. It shows all the entities here. Let me scroll down so you can see them all. There they are. You're probably already familiar with the Northwind database if you've worked with Microsoft products very much. Now, at first you might think that it's just a straight graphic of the tables, right, that are in the database. But it's a little different because those navigation properties down here are not necessarily fields in the table. ADO.NET can infer that there has to be a navigation. So, for example, order details and orders. Because order details has an order ID field, then the navigation from order to order details, the ability to navigate, is inferred by ADO.NET. Now, if you look up here at the tab, you can see model1.edmx. That's the name of it. That was the default name that I left. And then over here in the solution, I also have model1.edmx. And I can right-click that and view it a different way. I'll select Open with an XML editor, and if I do that, it'll show me a different view of it. Here's the XML view of it, and you can see that here I have an entity set for each of those tables, for each of the entities, I should say, all the entities from the database. Now, if I look over here, I also see that under the Model EDMX node, I have a C# file. Let me open that. So I'm going to expand here the EDM relationship metadata, and you can see here that it has navigation information. It shows foreign keys in the tables that they're in. So for example, you see that you can navigate between products and categories. Now down here inside the namespace, I'm going to expand the context areas, and you can see a class called Northwind Entities. I'm going to open up the constructors for that class. And here in the first one you can see, and actually in the second one as well, that lazy loading enabled is true. And I just want to show you that now, but I'll talk about it a little bit later. Down here in the second one, I want you to see the connection string. There are several constructors, right, that you can use, and one of them has the connection string as part of it. That's stored in the config file for this project, and it's used, obviously, to connect to the database when the code tries to construct a new entity in that way. Now I'm going to close contexts here and open up entities. And inside entities, you can see there's a class for each of the entities. There's one for categories, and got one for customer, and so on for all of the different classes. For all of the different entities, I've got a class. So I have all the classes that are in my model, Model 1, which was based on the database, and I can use these classes to create instances of specific entities, of customers or orders or products or whatever. Now I'm going to close the Model 1 designer code, the C# code, and I want to go to the form now. And I'm going to add a combo box. That combo box is going to display all the product names in a minute, so let me go to the code. I'm going to double click on the form itself, and what I want here is a Northwind Entities. Now those are part of the class that it pops up on IntelliSense because I added the model. So I've got a Northwind Entities. I'll call it NWENT. And then here in the form load event that I created when I double clicked on the form, I'll instantiate it. So I'll say NWENT is a new Northwind Entities. And then I'll go on and I'll set a couple of properties of my combo box. The data source is going to be the products table out of my Northwind Entities. And what will be displayed, in other words, my display member, is going to be specifically from that table, product name. And I only need one more thing. I need to dispose of that. So I'm going to go back to my form, over here to Events, do the form closing event, double click to create that event, and here I'll dispose of my Northwest Entities. My context object is what this is called. That's what I've created. Okay, that's it. I'm ready to run it. I can just push F5 or click Start Debugging, and that will of course build it for me first and then run it. And you can see there's my form, and when I click on my combo box, there's all my products. That was super easy. And the reason it was super easy is that behind the scenes, setting the properties of the combo box, the data source and the display member, made the context, the Northwind Entities, run a query against the database. So when I set it here, when I set those products, the query was run against the database, returned the results I needed to put into the combo box. I didn't write any code at all to open the connection or create the query. The context object did it all for me. To query entities in the EDM, you normally use either a link to entity expression or a query builder method expression. For example, here's a link to entity expression. We're selecting from the categories table every row where category ID is 14, every entity. And then the equivalent in this last line here, the last two lines, is the equivalent query builder method. The query builder has several other methods besides this where method here that you can use. In the resources at the end of this video, I'll tell you where you can get more information on all of the query builder methods on MSDN. I'm going to start by adding a simple little query to the application that we did in the last demo. So I'll go to my form, and I'll start by adding a text box to it. Now I'm going to double-click that combo box to get its changed event. And what I want to happen is when the user changes the value in the combo box to a new product name, then I'm going to show the category of that product in the text box. So to do that, of course, I'll have to navigate from the product entity to the category entity. So I'm going to write a link to entities query to get it. So first I'll get the selected item property from the combo box. And that is a product, so I'll declare product selected prod equals, and I'm going to have to cast this to a product, whatever's in the combo box, selected item. And then I'm going to use a query to select the categories where the category ID matches the selected items category ID. Now, of course, there's only going to be one, and I'll tell you now that this isn't the most efficient way to do it, but we're going to do it now to demonstrate a query. So that's a queryable of type category. And I'll call it a category query. And then here's my link from CN, and here's my entities, my context item, and I want all the categories where that category ID is the one in the selected product. And then I'll select, well, this will select all C's. As I say, it will return a list of entity objects, but in fact, there's only one entity object that's going to match. Still, I have to write it like this. And I'll call it cats, all the categories. That's the category query. And I'll convert it to a list. Now, I can take the first and only item in that list and get its category name and put it into the text box. Okay, let's run it to test it. Okay, chai is a beverage, and tofu is produce. Looks like that works. Okay, so you see how the iQueryable works. I'm going to change that now. I'll comment all of this out here. And I'm going to do the same thing, but this time I'm going to use a query builder. Of course, I could have put a using for this, but I didn't. Again, I'll call it the category query. Take my context object here, get the categories from it, and here's my where statement. So you can see that the logic of it is pretty much the same, right? And now I'm going to leave the last two lines the same. Oops, I seem to have lost one here. This should still be there, so I'll just move it down here and uncomment it, of course. Okay, and now I'm ready to run it again, and you'll see that the results are the same with this method of querying. So I get chai, that's a beverage, and pavlova is a confection. Okay, so both those worked, but it isn't really an efficient way to do it. It was really just to show you how to do these two kinds of queries. There is a much easier way to get the category name by letting the entity framework, your context object, do the navigation for you. So what we're going to do is to see how easy it is to get the category name even though it's in a separate table from the product, letting the entity framework do the work. So I'm going to copy these, I'm going to comment these out. And then down here, okay, I have a selected product. I'm going to navigate from it to its category, going to be handled automatically, and then to the category name. I didn't have to do a query at all. The entity framework is taking care of the navigation and matching up those category IDs for me. So let's run that. And we'll pick something else this time. Apparently kombu is seafood. Now, this all works, but it's not very efficient. I'm making a query, a separate call to the database every time the product name changes, because here in my selected image, in my selected index, I'm doing this query. So that doesn't make sense. So what I want to do is get the data from both tables all at once, and then hold it in a local variable so that I can manipulate and work with it. So what I'm going to do is go up here to the class level, and in addition to my entities object here, I'm going to add a list to hold category, call it cats, and a list to hold product, oops, and call it prods. Those will be all the prods. And then in the load, I'm going to instantiate them. I'll make myself a little room and do it right here. And the same thing for prods, of course. And now what I'm going to do is make sure that this query here in the selected list changed is gone. I've commented that out. And what I'm going to do, because I'm trying to avoid that, right? Now what I'm going to do is put my query right here. I pasted it in just to save a minute here. So I've got a query called category query. So when I say Northwind int categories, a query is going to be made against the database, and then the results are going to be assigned as a list to cats, and then it's going to do the same thing with product and assign that to prods. Now the query, the way I'm doing it here, doesn't have a where clause. I'm not matching anything up. I want all the data, and then that gives it to me so I can work with it however I want to in the app code. I can call or match it up however I want. I've got all the information in categories and all the information in products. And now I'm going to change the line here that sets the data source. I don't want to make another call to get that data. That's what I'm trying to avoid, right? So I'm going to say just get it from prods. You've made the call, and now it's there. And I don't have to change, of course, that display member property. Now let's run it again. Chai is a beverage, And Uncle Bob's organic pears are produce. It looks like everything is still working, but it's a more efficient application now. .NET 4.0 includes the second version of the Entity Framework, but it's called version 4 instead of version 2 to show that it's part of .NET 4.0. It comes with Visual Studio 2010, and in the Beta 2 of Visual Studio 2010, which is the one that's currently out there, you get the Beta 2 of the Entity Framework 4. And these are some of the new things in it. There's model first development. The designer can now start from a model and then generate T-SQL in customized code. And plain old CLR objects. That lets you generate POCO classes and customize your entities. And then lazy loading supports the deferred loading of objects from the data source when you're accessing a navigation property. Let me explain that one a little more. Lazy loading refers to waiting to get entity data that requires traversing tables until that data is actually needed by the code. Link to SQL allows for deferred loading like this, and now so does the Entity Framework. So for example, you can write this code here, and just by referring to orders, to the orders property of a customer, C.orders here, this bold part, then the orders data will be loaded at that point. By default though, lazy loading is turned off, so I have to set the context property lazy loading enabled to true. And using lazy loading means that you won't be fetching data you don't need, which just wastes time and bandwidth, because in any particular application, you might set up your query, but a particular conditional route, a particular path through your code might mean that you didn't use all that data, or perhaps any of it. So you can avoid fetching data you don't need, but then when you need it, you can get it automatically without any extra effort. ADO.NET detects that you're asking for data that needs to be fetched, and it fetches it. Let me start a new application here to show you some of these new features. I'll open a new project, and this time it'll be a console app. Call it ADO Demo 3 and leave it right there on the desktop. And now I'm going to start by demonstrating how you do model first development, which means I don't have an existing database, that I'm going to create the database as part of the project. So the first thing I'll do is to add a new item, and that will be an entity data model. I'll leave it with the default name Model 1 EDMX, like I did in the last demo, but this time instead of generating it from an existing database, I'm going to go to an empty model. And what that's going to do is give me a blank design surface here, and I'm going to create a couple of entities on it. I'll right-click and say Add Entity, and this one will be a course entity. And notice that as I type it, the entity set name is being created for me. By convention, that's the plural of the entity name. Also, I've got Create Key property checked here, so it's automatically going to generate a primary key for the entity. That's a lot like a primary key in a table, and by default it's going to call it ID, and the type will be int30. Okay, now what it's doing, or what it has done, is created a nice graphic for me here of this this entity course. Now this entity is going to stand for one of the courses on MS Dev that can contain multiple individual training videos, like this video you're watching. This one, along with several others, is part of a course on Visual Studio 2010 Beta 2. Now I also want this to have a name, so I'll right-click and say Add a Scalar Property. And that property is going to be course, name. And if I look over here in Properties, you can see that the type is string. New properties you create default to string, but you see that I can set it to any other data type. By default, it is not nullable, and of course I can change that also. And then by default, it's not an entity key. For one thing, I already have an entity key. So I'm finished with this one now, and now I'm going to create another new entity, and that one's going to be named Video. And there's my entity set videos. I'm going to go ahead and create a key property for that one also. Now I could change that if I wanted. You saw that that's just the default. going to go ahead and give it a name also, video name, and it defaults the same way that course name did. That's what I want, so that's fine. And now what I need is an association between courses and videos. What I want to do is show that one course can contain many videos. So I'm going to right-click here and add an association. And the association name is going to be Course Video. And you can see that one end is course and the other is video. And the multiplicity is one course to many videos. If that's not the multiplicity I want, I can change it. Because these are checked here, I'm going to have a navigation property in course called videos. That is, course will have a collection of videos as part of its properties, and video is going to have a navigation property that goes back to one course. So it'll have the ID of a particular course as part of it. And I've clicked to say add the foreign key property that I need in the video entity. In other words, in order to navigate back to course, it needs a foreign key, so it's going to add that for me. Going to put down two navigation properties to show what can navigate to what, and then also add the foreign key properties that I need. So I say OK, and there you go. I've got my navigation properties now, and I've got my foreign key here so that I can get back to course. And I've got drawn an association between them, and there's my multiplicity, one to many. And now my model, which is obviously very simplified, is finished. I'm going to go ahead and save it. And so now I can take this diagram, this entity model, and I can create a database from it. Now, of course, I might need to have others review it first or validate it in some way, but whenever I'm satisfied that the model is complete and that it's correct, I can go on to the next step, which is to generate the SQL scripts to build the tables I need in my database with the correct properties to match this entity diagram. Now, I'm going to generate the database from the model, but I have to start by creating an empty database to put it into. So I'm going to go over here and open my Server Explorer window, and I'm going to add a new data connection. So I'll right-click on Data Connections and say Create a new SQL Server database for me. Now, the server name that I'm going to attach to has to be specified. It'll come up in a second here. There it is. And then I'm going to use Windows Authentication just because that's the simplest. And I have to give the database a name. I'm going to call it My Demo, and it's going to create a new database for me with nothing in it, just the database. There it is. I can see it over here. If I go to Tables, you can see there's nothing in it yet, but I do have the shell of the database to work with. So now I'll go back to my model, right-click and say Generate Database from Model. And I have to tell it what data connection, and I want that new one that I just created, My Demo. Here's my connection string, so I can see how that looks. And down here it says Save the Entity Connection Settings in my app config file. That's well, you can't see it right now, but it's over here in my Solution Explorer. And the name is going to be Model 1 Container. So Model 1 Container is going to be my context object. All right, I'm going to tell it not to include sensitive data, that's your password, right, in the connection string, that I'll take care of that in the code itself, in the application code. Okay, now it's generating the DDL, the data definition language, the SQL, to create the database. Here it is. Now I can see it, I can review it at this point. I can't edit it here, but I'll have a chance in a minute. And I'll click Finish, and this script is going to be added to my solution, but first I have to say that it's okay to override anything that's already there. Okay, now I can close this so you can see that I now have this SQL in my database, in my project, and it's also been opened up here in an editing window. And because this is an editing window, I can actually edit here. I can make changes if I need to. Okay, then if I'm happy with it, if I'm ready, I can right-click on it, and I can tell it to execute the SQL. Well, right now you can see I'm not connected to a database, so the first thing I have to do is connect to the correct server. That's already there. Make the connection. The query runs very quickly only because this is a very, very tiny little script. But the command did complete successfully. So now my database has been created. I'm going to close all these open windows. And I'm ready to write some code. The first thing I need to do is to get a context. So I'll start here. I'll just use a using statement here. And remember our Model 1 container. That's my context. Now, inside this using here with the context, I'm going to instantiate a new course, a series of videos. So I'll say, this is the name of it, VS course. That's a new course, and you can see that I'm getting the IntelliSense here, so that tells me that Visual Studio knows my schema, knows the entities. And I'm going to set the course name. Call it VS 2010, and I'll set the ID. That's the first course, so we'll call it 1. Now I'll instantiate a couple of videos to be part of the series, and I'll make a collection here. Call it vids. I'll have an array of 2 here. The first one is a new video, and I'll give it the ID of 1 and the name ADO.net. Now I'll do it again for the second one. I'll just copy that and make the changes. ID is 2, and this one will be ASP.net. And now what I want to do is set up the navigation. I want to connect the videos to the course using that navigation property that the Entity Designer added for me when I told it to create an association between courses and videos. So vid0, the course for that, is VS course. And for vids1, it's the same, belongs to the same course. And I want to be able to navigate the other way also, so I'm going to add the videos to the course so that I can also move from the course to those. And I'm going to use a for each loop to do that. For each video in my little collection, I'm going to add it to the videos collection of my course. And now I just need to, I've got this all set up, I just need to let the context know about it. So I'm going to say context to the collection of courses, the entity set courses. I'm going to add an object, and that object is VS course. And then finally, I'll need to save those changes. So now I've created data for the database, and now just to make sure that everything's working, I'm going to read it back out. But you can sort of imagine that this might be what the code would look like if it were in another part of the application, another project within the solution, or perhaps another application entirely. So for each course that's in our context of courses, we're going to do a write line. Oops. and we'll get the course name. And then also for each course, I'm going to loop through all the videos that are part of its videos collection. Now right here, where I'm saying c.videos, I'm going to use that navigation property to move from a course to the videos. And when that happens, the lazy loading is going to occur. At that point, the navigation is performed and the data is fetched. So for each of those, I'll write again. And I'll indent them a tiny bit so they're easier to see, and write the video name. Close that for each loop. Close the other for each loop. And I think I'm done now. I just need to add a console read line at the very end. And I can see a little error right there I need to fix for each video. And it looks like I've got an error there too. That ID was supposed to be 1. Okay, I believe I'm ready to run it now. We've got a build going on, and when that finishes, I'll see if I get that output printing out those 2 courses. And there we go. It worked. Okay, so now next let's look at the classes that were created automatically as part of this. I'm going to open my model1designer.cs file, my C# file, and you can see here that classes were automatically created. Oops, I want entities, sorry. For course and for video. And if I open those courses, you can see that there's really a lot inside. There's a factory and the properties. It's quite a few lines, right? And then my navigation properties. So this is quite a long file, considering that they're just relatively simple little classes. That's what the automatic code generator created, and that's fine. But it's possible that I might want to write my own classes, what they call POCO classes, right? That POCO stands for plain old CLR object. So here's how I could do that. First of all, I'm going to open my EDMX file again. I'll click here so that I'm accessing the properties of the model as a whole. And under my code generation strategy, instead of default, I'm going to say none, so it won't try to generate classes for me. And then doing that, just making that change right there, actually wipes out this file that had all that code. See, it's gone now. That code doesn't exist anymore. So what I'm going to do now is write my own code, my own plain old CLR objects, the POCO objects, for the classes that I need. I'm going to just paste that code in to save a little time. So what I've pasted in here is just very simple classes. I've got my usings. I've got a class course. It's got a constructor that sets up my list of videos. Got a few properties, ID and course name. And then for my videos, I've got an ID, a video name, and a course ID as properties. And then also a course itself, the full course, the course object. That was pretty easy, but I also have to write the context class. I'm going to keep the same name so my code still works with it easily. So I'll call it Model1 Container. And its type is an object context. Now, if it's going to inherit from object context, in the constructor, I want to call the base constructor because it needs to have a connection string passed in. There's already one in the project, right? The one that was generated earlier. So let me get that in there. So here's my constructor, Model1 Container, and I want to call the base and pass into it the base constructor. And then inside it, I'm going to make sure that I can do lazy loading. So I'm going to take my context options. Oops, I can see that I accidentally have braces there instead of parentheses. There we go, that looks better, huh? Now, in my context options, here they are, I want to take the lazy loading enabled and set that equal to true. So there's my constructor. I'm also going to need interfaces for the object sets. One for course. And in the get, I'm going to return the create object set for all the courses. And now I need the same thing for videos. I'm going to just copy and paste this. And then that's it. I just need to close here. That's closing the creation of my Model 1 container, the context. And now I'm going to run, and let's see what the output is. Oops, one short here. Oh, I see, it's up here. There we go. Let's try running it now. Whoops, I got a little violation of my primary key constraint. I can see over here that that's what the problem is. And I know why that happened, because when I ran it the second time, I was putting back into the database the same primary keys here. So let me make a quick change there. I'll have to stop debugging. And I'll just change these so that they're acceptable. And we'll make this one 3 and 4. Now let me save everything, and we'll run it one more time and see if we can get it to work with my POCO classes. And there they are. There are also other features that I haven't covered in this video. Complex types. The model designer now supports complex types. And user-defined functions. Entity SQL supports user-defined functions in a query. Coding only lets developers bypass the model altogether and just write the code straight. Testing, there's a new interface for testing that makes agile development easier to do. And then in-tier applications, there are new APIs and templates that are specifically designed to make it easier to develop in-tier applications. You can get more information on these from the resources that I'll give you at the end of this video. There's some more big changes that are scheduled for ADO.NET in Visual Studio 2010 that haven't yet been incorporated into a public release as of the date of this video. Those are changes to the ADO.NET Data Services framework, which is being released in a new version. It has a lot of new features, some of which are here. The custom data service provider lets you build an ADO.NET data service over any data source. There's a new data service collection class to give you automatic change tracking on client-side objects. There is blob support, so you can stream to or from a data service. And there's some new ways to control what's returned from a query, like you could return a count of the result set only, or a limited subset of the result set, or a subset of the properties of an entity instead of the whole entity. Now, the release candidate of Visual Studio 2010 is probably going to be released in February of 2010, so you can keep your eyes out for that. But in the meantime, you can experiment with these new features by downloading the second Community Technology Preview of ADO.NET Data Services. It's version 1.5. That's already available, but it's available for Visual Studio 2008 and for the .NET Framework 3.5 SP1 only. Now, since this is a video about Visual Studio 2010, out of that 2010 series, I didn't cover these new features here, but I do have the download site in the resource pages for you. And here are some resources to help you with ADO.NET in Visual Studio 2010. Now, the first is the home page for the Beta 2 and for .NET Framework 4, and it has download links for both of those and other tools also. And then the next is the MSDN reference on Query Builder methods. And if you want to get a jump on what's expected in the next release of Visual Studio, the download sites for the ADO.NET Data Services CTP that I mentioned is here. There's two versions of it, one for Windows 7 Server 2008 R2 and another for earlier operating systems. Now, I know that those are long URLs, so you probably should just go to the Microsoft Download Center and do a search for ADO.NET Data Services. The latest version was just released in December of 2009, so look for that one. And that's some of what's new in ADO.NET in Visual Studio 2010. The source code for my demos from this video and others are on my blog at the URL shown here at the top, and I'm announcing it on Twitter as new videos are posted. So if you'd like to know what's available and when, you can follow me on Twitter at nstrickland1. Thanks for watching. Bye-bye.